All right, we're in section 5.5. We're going to use inequalities in a triangle. Now, the side lengths and angles of a triangle have a particular relationship. So, looking at these two triangles here, the one on our left talks about, it gives us the side lengths of that particular triangle, where it says that it's 4, 5, and 7 units respectively. The one on the right gives us just the angles, where it's like 100 degrees, 50 degrees, and 30 degrees respectively. Here is what we can look at. When you are trying to identify um, angles, when all you're given is the side lengths, all we can do is say that the largest angle of any particular vertex on a triangle is going to be located opposite of the largest side length. So in this case here, my largest angle is going to be on the opposite side of my largest side length, which is 7. So this right here is going to be my largest angle. So it's largest angle. And then the next largest angle would be the value that's, the second largest side length. So it's going to be the opposite vertices. So again, right over here, so this is going to be the second largest angle. And then finally, my smallest angle is going to come from the side with the opposite of the smallest side length. So it would be right here. So this would be my smallest angle. And then the same thing goes for if you're identifying side lengths. The largest one's going to be the opposite with the largest angle. So if I have 100 degrees, that's my largest angle. The opposite side is going to be my largest side. Same thing goes here, second largest and third, respectively. Okay. So that being said, this example here is they want us to list from shortest to largest side. So the shortest side is going to come from the opposite side with the smallest angle. So I'm trying to find my smallest angle, which is right here, and that's going to be on that opposite side. So my smallest side to start with is going to be ST, comma, and then the next one is going to be the opposite of this 30 degree, which is RS, and then the largest one comes from the opposite of 121, which is going to be RT. Okay? And then here they want us to list the angles from smallest to largest. So the smallest angle is going to be opposite of the smallest side. So my smallest side is AB, which is 4. So that means that the smallest angle in this case is going to be angle C. The second smallest will be angle B, because it comes from here. And then the largest angle is going to be angle A. Okay. Looking on this page, I wanted to show you what is the possible sides of a triangle. So first off is I made a base of 5 inches, and if you look at my straight edge here and measure it over to 5 inches, you see that it's 5 inches. And what I did was I took a compass and I struck marks at 4 inches and 3 inches here, and where they intersect, I was able to make a triangle that was 4 inches on this side and 3 inches on that side. The thing is not every combinations of side lengths are going to work, because if you look over here, have a base of 5 inches, but I tried to make a side length here that's 3 and a side length here that was 2 inches, and they don't intersect. So this one here, I could not, those particular side length combinations would not make up a triangle. And that brings us to one of our theorems, and it's going to be called the triangle equality theorem, which basically says that the sum of the two lengths of any two sides of a triangle has to be greater than the third side. So if I took the sum of AB and BC, that has to be greater than whatever the side length for AC. And then same thing goes for the other ones. AC plus BC must be greater than AB, and also AB plus AC must be greater than BC. So using that theorem to kind of help us solve problems is going to be beneficial. So if we look, this example here, it says a triangle has one side length 12 and another length of 8. It says describe the possible lengths of the third. So you have one here that's 12. I have one here that's 8. Now I have to figure out what this value here must be. So all I'm saying is that if I take any two of the combinations, I'm going to say 8 plus x, it must be greater than 12. So plug it in there. I subtract 8 from both sides. I go over here. X is greater than 4. And then if I were to even look at another root, I would have to say that x plus 12 must be greater than 8. So go over here. If I would subtract 12 from both sides, I would get x is greater than -4. Well, -4 is not a distance you can use, so all they're telling us is that x must be greater than 4. So anything that's greater than 4 will make that into a triangle. Here it says describe the possible values of x. So what I'm going to do is let's take 5x minus 9, and I'm going to add it to x plus 11, and that's got to be greater than 2x plus 10. Okay, I got my like terms here, so now I got 6x plus 2 is greater than 2x plus 10. I'm going to subtract 2x from both sides, so I get what? 4x plus 2 is greater than 10. And then I subtract 2 to both sides, so I got 4x is greater than 8. So that means that x must be greater than 2. And then since it's a variable, again, I'm going to try another set of circumstances. So let's take the x plus 11, and I'm going to add it to 2x plus 10, and that's got to be greater than 5x minus 9. Like terms here, so I get 3x plus 21 is greater than 5x minus 9. All right, I'm going to subtract 2x from both sides here, or 5x, I'm sorry. Subtract 5x from both sides, so I get negative 2x plus 21 is greater than negative 9. Subtract 21 from both sides, so I get negative 2x is greater than a negative 30. Dividing both sides by negative 2, I get x is less than, remember you have to flip the inequality when you divide by a negative number, x is less than a positive 15. So I got x is less than 15, and I got x is greater than 2. So you can leave it like that, or you can say that you can put 2 over here, 15 over here, and x has got to be in between these two. So it's kind of like an and statement. Okay, and that is being able to use inequalities in triangles. Hope this helps. Until next time.